Okay, so if the stack had a last in first out uh, setup, a queue would have a first in first out setup, so wherein the first element inserted into the queue is the first element to be out or removed from the queue. So basically, you can also use the push pop and peak operations, but to be more uh, to already be sort of associated to the queue. Already we use the enqueue and the queue operations. So enqueue puts an item in the queue, and the queue removes an item from the queue. So queues, as they are in real life, or how they should be in real life, the first one to arrive should be the first one to get serviced. And then if you're the last one to arrive, you should be the last one to get serviced. So that's for a regular queue. Now, just like in real life, we can also implement priority queues wherein we have certain elements we can give priority to. But that will be for a future topic since that's actually not a linear data structure or a linear abstract data type. So a visualization of uh, the queue can be found in the lecture notebook as well. Hopefully you can follow the steps that go through it. And then obviously like the stack, we can implement the queue using the dynamic array or the link or a linked list wherein uh, enqueue and the queue would be delete and insert operations, and then either you always enqueue at the start or you either always enqueue at the end, and then vice versa, you always dequeue at the start and then enqueue at the end. But since our worst case for the dynamic array is when we insert and then have to reallocate, let's just insert at the start since that would always take longest. So we preserve the constant worst case runtime for the queuing. Now, for a linked list, if we have a singly linked list, either enqueue or the queue would take off and time, depending on whether we insert at the start of the linked list or at the end. But to call, we also have what we call a doubly linked list, where we have pointers to the start and the end of our list. So for a doubly linked list, in order to enqueue, we just push at the front, and then whenever we dequeue, we pop from the tail. So obviously for the three AD or for the three implementations given, double linked lists have the better running time across for all the operations needed. So why when would we implement it as a single linked list instead of a double linked list? Basically, it's just a if we are limited and we can't really implement a double linked list due to either memory constraints or it's too hard to think about. So it basically means the added complexity of the of making a double linked list work is should be worth it in this case since we always have a constant running time for all the three operations. So I think that's all I have to say for the Q ADT, and let, let's go to the next video.